Kedarnath sir, shall we start, sir?
Yeah, sure, ma'am.
Yes, sir. So I'll say the introduction. So, good afternoon, all. On behalf of V8E AP University and School of Computer Science and Engineering, myself, Dr. Suma, Associate Professor, Department of Artificial Intelligence and Machine Learning, under the School of Computer Science and Engineering, V8E AP University, and Dr. Ishwaraya Rayachoti, Professor, Department of Networking and Security, under the School of Computer Science and Engineering, V8E AP University, who are the coordinators of this event, officially declare the 5-day hands-on workshop on DevOps 101, Build, Ship, and Scale Smarter is open. I welcome all the participants for this wonderful workshop. Your cooperation towards registration process is highly appreciated. I'm very glad to introduce our resource person, Mr. Kedarnath Grande, Senior DevOps Engineer, TransUnion, Hyderabad, Telangana, India. He has completed his bachelor's degree in information technology in 2014 in RGM College of Engineering and Technology. Coming to his experience, currently he is working as an senior DevOps engineer, TransUnion, Hyderabad, Telangana, India. He also worked as senior site reliability engineer, infra cloud technologies during 2022 to 23. Worked on CBDC product in NPCI project, and also worked as senior DevOps engineer, New Star, between February 2021 to December 2022, and also worked as principal technical consultant in High Radius, September 2014 to February 2021, Hyderabad, Telangana, India. He is seasoned DevOps and site reliability engineering professional with 11 years of hands-on experience in designing scalable, continuous integration and continuous delivery or deployment pipelines, managing cloud native infrastructure, and driving automation at scale. His career has spanned multiple industries where led DevOps transformation, improved system reliability, and reduced deployment cycles. He is holding certification includes like Certified Kubernetes Application Developer, Google Cloud Computing Services, and ACE. He is also passionate about knowledge sharing and community growth. With this eminent profile, I welcome Mr. Kedarnath Grande to this workshop titled DevOps 101, Build, Ship, and Scale Smarter. Today's session is about what is DevOps, why do we need it, how is DevOps different from SRE, DevOps versus traditional, DevOps principles and lifecycle, the infinity loop, DevOps phases and tool chain overview, real world examples. Now I'm very delightful to hand over the session to Mr. Kedarnath Grande. I invite him to start the session. Thank you, sir. Thank you for being with us. Thank you so much.
Thank you, ma'am, for a wonderful introduction.
Thank you, sir. Thank you.
Yeah, I hope you are able to see my screen, the presentation.
Yes, sir, we can see your screen. Yeah. Yes.
Okay, so as mentioned earlier, this session today is regarding DevOps. There will be subsequent sessions on GitOps, microservices, containers, container orchestration, and cloud IAC and open source software. So today's session is DevOps. My introduction was already given, so I'll just skip this slide. So yeah, this is a typical basic question, but very important question. It's asked in many interviews, and if you want to get started with any of the technologies in DevOps, you first need to understand what is DevOps. So yeah, there's no wrong answer. If anybody can speak up, they can yeah, tell me what you think DevOps is. Let's make this interactive, okay? It's not like only one-way traffic.
When you want a smooth workflow,
yeah, a bit louder, please.
When you want a smooth workflow for production.
Yeah, Surya. That is one definition. Anybody else?
DevOps is a culture or practice adopting in our organization, which increases the ability to application delivery.
Okay.
So combined framework of development activities along with operational activities for a smoother working.
Okay, so development team and operations team coordination basically. Okay, So yeah, let's discuss few things first, and we'll understand what the definition means, right? So let's say if we are starting a software company, most likely a product-based company, we are responsible for some application, web application or something. We have a product. So what do you think is the goal of a software company, any software company, right? The goal of software company is to deliver any application, their product to the end users. And of course, there will be many parameters like the application needs to be of high quality, the application needs to run well, it needs to perform well, right? Only then will people use our product. So uh, in order to develop such an application, there are several strategies, but the most oldest one and the newest one, I just gathered them. One is waterfall model, and the other one is agile model. So earlier there used to be waterfall model. At its core, all these models are used to develop this software or a product which you want to launch and deliver it to the end user. So waterfall model, while straightforward, suffers from significant drawbacks. Its rigid, sequential nature, makes it difficult to adapt to changes. You can't. It's a one-way flow. You can't, go back to previous steps. Uh, there are several drawbacks with this, but it was enough to get started, and people used to adopt this waterfall model at earlier stages, right? So, and there is agile model, which is basically aimed at resolving some of the drawbacks of waterfall model, right? Each step is split into iterations, so that when you complete a phase, you get a feedback, and based on that feedback, you fix the application, or enhance the application, and then go to the next phase. So there is team collaboration, but it's minimal. Project is split into iterations, and but it also gives rise to a famous problem. It works on my system, which we'll see in the later sessions, right? So several agile methodologies are there. So agile model is different from agile methodology. Okay, methodology is something that implements this model. So there is Scrum, Kanban, many other things are there, methodologies which implement this agile model, um, to make the software release process smooth. As we'll see going forward, DevOps can be seen as an extension of agile principles, applying them to operational aspects of software delivery. So let's look at this software release process. It's famously called as SDLC process also. You might have learned in your curriculum and all. So the initial starting point of any software release process is having an idea. Okay, we get an idea, like, okay, let's develop this product. This will work. Okay, I need to build this, something like that. And you start writing down your vision, right? You start noting down your product specification details, requirements of the software, functional, non-functional aspects, both. The design also involves, architecture, how the components should interact with each other, user interface, database design, all the system design concepts as well. So for our convenience, let's put all that into this requirements step only. After you note down all these requirements and everything is ready and documented, you start hiring developers, or you start writing code yourself, and based on these documents, they start coding the product. So once the product is, code for the product is written, the testing team or someone will be there to test it, so that any bugs are identified and fixed. And once this testing is approved, you start building the project and packaging it. What this step means, for example, is you use Maven to build a jar file in case of Java applications, something like that. Okay, once this is packaged into some compressed file, you deploy it. The deployment phase, like, it involves making the software available to users. Like, you have a environment in cloud or on premise, you start running this packaged software, and make it available to users. When people type some URL, they start accessing your application. So is this the end? Do you think the deployment is the end of this software release process? it shouldn't be. There is another important step called operation and monitoring. When you run the software in the production or servers, you need to monitor it. Is it up and running? How is it running? How much resources it's occupying? Do you need to increase the resources or not? Several things come under this operate and monitor section, right? So all these steps, which the flow which you can see right now, it's part of the initial launch. Okay, it's by no means an end. It's a initial process, like from an idea to initial deployment of your product. It's the these are the steps or the flow, right? Now when you operate and monitor, as I said, you will start seeing some bugs. Maybe you need to do bug fixes. You need to optimize performance so that the resource consumption like CPU and memory are less consumed or efficiently consumed, a better way to put it, right? So, and you may want to add new features based on some feedback from the customer or someone else. So you want to add new features, but how would you do these? Like you need to put this new, let's say you have a new feature idea, like a new product page or something. Then you put that into requirements, code it, test it, build again the same steps again, right? So that will be there. Every time you make a change, it needs to be tracked, obviously. So if there are so many improvements being added continuously, like how are they tracked and maintained? So this is where versioning comes in. So in update 1 you push some changes, update 2 you push some other changes, new features or maybe bug fixes. Okay, so every change is called an update, and every update needs to be tracked using versioning. In typical software environment or software world, this versioning is a standard process where you have like three things, like where ABC are numbers. A is like a major change. You make, when you make changes in framework level, then that's a major change. The A letter will be, I mean, the number in the A position will be incremented.
Sir, Kedarnath sir, your
Yeah.
voice is little breaking, sir. Your voice is little breaking.
Okay. Is it better now?
Yeah, breaking actually.
Okay.
Now try, sir.
Is it fine, ma'am?
Yes, sir. Now it's fine.
Okay.
Yes.
So
Okay.
yeah, the number in the position B is used for minor code changes or new features, and C is for patching the small bugs. So let's say the initial version is 1.0.0, and you are adding a new feature, then that becomes 1.1.0. And when there is a framework change, the first position number where the A position denotes it, right? 1, that is incremented.
Sir, actually it's breaking, sir, again. There is a network issue, might be.
Is it fine now, ma'am?
No, sir, no.
It's fine.
Anyone, any other student, please respond. Is it breaking,
For us,
students?
clear, ma'am. For us, clear.
Yes,
It's
right?
clear, ma'am.
Clear,
It's
clear.
clear for us.
Or it's breaking for me? Is it
Yeah,
clear,
I
students?
think they are saying
clear
it's clear
for us,
for them.
Yes, ma'am. It's clear.
Yes, sir. Just type in chat window, no? It's clear means please type in chat window. Anyone?
Yeah, I think it's clear for them, man. Okay, so if there is a framework change, again the major version is updated.
Clear, sir. You can continue.
Yeah, thank you. And for minor fixes and all, the last digit is updated. So even if you see, let's say for example, Ubuntu, a Linux operating system, right? Its version is also like 22.04 point something, LTS, long-term support. All these basically follow the typical standard of A.B.C. Right. So coming back to our phases involved in developing software, uh, you start having a new, when you want to add a new feature, you start putting down that idea into requirements, that code it, test it, build, package, deploy. It becomes a cycle. You do this process of fixing small or major things and improve your application over and over again. Like you have an idea of improvement, you implement it, code it, test it, build and package it. So once it's released, you observe and maintain it in the production to see whether there are any new improvement possibilities or any issues that can be fixed right away. So this gives you a process of continuous delivery of changes and endless cycle of improvements to the product or application, whatever it may be. And DevOps is about making this process of cycle fast and smooth with minimal errors and bugs. So with DevOps, improvements get created and delivered to users not only fast, but those improvements need to be of high quality. Okay, and they need to be well tested, because the product shouldn't have bugs. Any ideal product shouldn't have bugs. So which actually becomes a big challenge. Uh, quickly delivering high quality code is the challenge. But as you can see, we have the agile models, we have all these theoretical things, right? But why is this a challenge? Because everything works in theory well and enough, but when you try to implement it, there are several issues or roadblocks in every phase of this cycle, right? Which actually slows down the cycle of release. uh, Time, a lot of time and effort is consumed to overcome a single barrier in each of these phases. And because it takes longer time, there might be higher chance to, you know miss some of the errors, and they might slip into the production. Okay, so let's look at some of the roadblocks which may cause these things, right? Slow down of cycle release or something like that. So let's look at the first one. There is a development team in any product based company that actually writes code and develops the application, right? And there is operations team in the sense they maintain the application in the servers. They operate at the last phase of our cycle, where you are running your product in the production servers or on premises cloud, maybe on premises servers, whatever it is, and they make sure it runs properly and is up most of the time. Okay, so there might be a gap between these two teams uh, in terms of communication. Okay, that causes this barrier. Okay, from a developer's perspective, they wrote the code, but they don't know where it's being run. They don't know if it's running in the cloud or if it's running on premise, what kind of servers are being used. They don't have any idea about it. Okay, and they don't even consider where it's about all these things. Actually, they just write the code, they push it and hope that it works. But the operations team, they know all these things, but they don't know how the application is written. Okay, so will upgrading something break the application? They don't know about that, because they don't know how it's written and what tools and technologies are internally used to develop it. The most common form of communication usually in companies between these two is documents, like a Confluence document or KTs, all these things, right? So frankly speaking, in the agile model, people are always chased by deadlines. Okay, everybody wants to get things done and mark it as completed. So these documents, they need a lot of time and effort to write everything and document it. So it's not done well, because they don't have the time to do it, and they are chased by deadlines. Okay, there is no clearly defined automated process. So automation, again, it involves people to have time spent on it to automate things. When they are busy pushing features into the production, they don't have time to automate it, and everything becomes a complex process. And each team is dealing with the manual work, like checklists and manual documentation. So all these things, again, they delay the release process. And yeah, it wastes a lot of time, which is not ideal for any company. Any features for any product based company, it hopes that all the features are moved into production and users have access to it as soon as possible. Okay, the second roadblock, if you can say. So unaligned interest. So as you know, development team is focused on features while the operations team have different goals. Okay, the difference in goals of each team is this roadblock here. Okay, development team, as I said, it's focusing on faster development of new features, while operations team resists the speed of release, because when they have a working product in the production, they are satisfied with it. They don't want new changes coming in frequently, because they are afraid if something breaks, then they are responsible for it, right? They work in shifts. They, if something breaks, then they are like operations team is held responsible. They are tortured, right, to find the root cause within. If development team has some deadlines like a month or a week to develop some feature, the operations team is given hours to fix it. You don't want your application to be down for more than 2 hours, 3 hours, right? So they have to be very fast, and they are held responsible with strict conditions. So they will resist the speed of release. They want to make sure every change is 100% safe and it doesn't break anything. Okay, stability of the environment and product is their priority, not the new features. Okay, so as I said before, production is operations team's responsibility. Developer may not be careful about the environment as much as operations, because they are not held responsible for that. The company goal is to provide new features while maintaining the stability, but the team goals differ among the teams. Okay, this again causes friction between the teams and release time takes longer. Another roadblock, similar to operations, there is another team called security team. Okay, they also have their own set of challenges and problems that cause delays or roadblocks, and it will stop the deployment. Okay, while the operations team thinks, okay, any change, will it affect the system stability? The security team has a question like, will it affect the system security? The change you are moving, does it open any loophole for the hacker to, compromise the product? And some products have like sensitive data, and if that is leaked, then it causes legal concerns, and the company can just go bankrupt or shut down. So it's at that scale. So security team has a lot of pressure on them as well. So this is again a complex bureaucratic process. Every change needs to be manually documented, and security team has to check for CV vulnerabilities and all the stuff like, is it the security patched version or is it a vulnerable version? So all this process again causes delay in the release process. Similar to operations team and security team, there is a team called testing team, and they have the another question like, is this change introducing any bugs to the application? So testing is performed at various levels, obviously. So end-to-end tests, unit tests, specific features need to be tested, regression testing, I just listed few of them here, but there are several of these, right? And all these are actually done manually, and they can't completely rely on automation, because the tests may vary among various levels, right? So this also, whenever there is manual work involved, obviously it will take a lot of time. So on these, all these above, roadblocks which we discussed, there is a lot of manual work involved. For security team, no, sorry, for testing team, we saw the testing that's done manually. For operations team, they have to maintain the servers, right? So some people do execute commands or give permissions manually, and if someone remove the permissions manually, it's very hard to track who did that in which server. If there are 1 or 2 servers, it's fine. If there are hundreds of servers, then that becomes a nightmare, right? So there are some cron scripts being triggered that will do this patching automatically. Sometimes the cron doesn't run because the server is overloaded, or you may have to restart the server. So all this manual stuff is also there. And for security team, they have to do these checks manually, encryption checks, renewal checks. They have these keys that encrypt the data in transit, data at storage. All these will be expiring, and they have to manually renew them going forward. So all the manual work is there for all the teams. And this, whenever the manual work is there, it is error prone, it is slow, and it's difficult to share knowledge. Whenever a new member comes in, there will be tons of KTs and tons of documentation for the new guy to read and get to the level where they can work independently. There is no transparency, obviously, because if there was some patch, as I said, in operations team, if someone executed some command in hundreds of servers, how do you track that, right? Hard to trace and replicate who executed what and when. This all again delays the release time. So as we have said, among someone said it's a collaboration between development and ops. It's correct, but to a certain limit only, right? So there is testing team, there is security team as well, but these are not all. I have just listed popular roadblocks which are there in the release process, right? Development team, it doesn't just deal with development and ops team. They are involved in everything. They can go beyond development and ops to make the process smoother. Which process? The software release process. The goal of DevOps is to remove the roadblocks which may come in the software release process. It removes those roadblocks and it will make sure that the product is delivered with high quality as fast as possible, right? So yeah, again, this is the same thing. DevOps aims to remove all these roadblocks and things that slow down the release process, whatever that may be. Okay, so that you will have a continuous cycle where you can fix bugs, add new features, optimize performance, whatever it may be. Instead of manual inefficient process, DevOps also helps create fully automated streamlined processes for release cycles. So this is the actual definition of DevOps intended by the founders. It's a combination of cultural philosophies, practices, and tools. It's a combination of anything that creates the process of releasing the software with faster and with high quality. Now, again, when people read this definition without understanding the context before, they were confused. This is like a broad way of defining anything, right? So what does anything mean? Like, they didn't understand that vague word, right? So different companies adopted different, they understood things differently, this definition differently, and they started their own DevOps implementation, right? So there are different companies, they have started their own implementation of what they understood from the common definition, and most of these companies, they arrived at something similar called DevOps engineer role, right? Again, it's not all the companies, it's just some companies that arrived at the same notion of DevOps. It's that there need to be some team or dedicated resource that handles all these process of removal of roadblocks and all, right? So that's how DevOps engineer came to be. And let's look at some of the frameworks, right? Frameworks in the sense different implementations also popped up when they looked at that definition, vague definition. Different people came up with different things, as I said. So these three are some of the popular frameworks also that came up at that time. So CALMs, these are principles, like it stands for culture, automation, lean, measurement, and sharing. What does it mean? Like, what does culture mean? Basically, culture defines it's like Indian culture. We use that there, right? So it's similar to that, but in a software terminology, it emphasizes on creating a collaborative, empathetic, and learning oriented environment. So people should always learn and look for new ways to solve any roadblocks that may come up with evolving technologies, where teams share a responsibility, and are empowered to innovate. The next one is automation. So automation focuses on reducing the manual work. Manual work is error prone, so it needs to be removed. It needs to be automated. Wherever possible, the tasks need to be automated, which makes the release process faster and less error prone. Lean means it needs. Sorry, does anyone have any question? Okay, so lean in the sense thin. It should discard all the unnecessary waste. We need the workflows, whatever workflows involved in deployment that application, they need to be optimized. They need to eliminate waste and ensure continuous improvement throughout the product lifecycle, from the start of the product to its end. The M stands for measurement. Measurement involves, using data, metrics to track performance, identify areas for improvement, and make the decisions informed, right? So you are just keep on going on and making changes on bug fixes, but how are you measuring things? So that's what measurement deals with. So the next one is sharing. Sharing is nothing but whenever there are new people coming in, they need to do this work, right? So you need to share this knowledge, document it properly. It's not like just for the sake of it. It needs to be clear and concise document. Whenever someone reads through it, they have to be able to do that work just by reading the document, right? It promotes knowledge sharing, collaboration among teams. It needs to foster transparency and a sense of collective ownership. So that is what CAMs deal with. And the next principle or framework that comes into picture is the three-way team. So it was introduced in Phoenix project. So the first one, or the first way they call it, is flow. It's by optimizing the flow from left to right. Left in the sense development, and the right is the operations. So the goal of the first way, the flow, is to make the delivery pipeline as smooth and efficient as possible, so that there are no bottlenecks and delays. But what does it mean exactly? So there are some key aspects that follow this flow. It's like systems thinking, value stream mapping, continuous delivery that makes this flow smooth and fast. When you automate the build, testing, and deployment processes to speed up releases, it basically follows the first way, that is flow. The second way is the feedback. When you think about agile, it is looking at the feedback only. It is breaking the every project into different iterations, right? So at the end of every iteration, you are taking the feedback and you are rectifying the process or improving the process and doing that iteration again. So it focuses on creating and amplifying feedback loops throughout the entire value stream. This includes maybe automated tests, provide immediate feedback on code changes. The key aspects where this feedback way is used is monitoring, alerting, logging, fast feedback mechanisms, like developers receiving pager alerts. There are some tools called pager duty, where whenever something goes wrong, it triggers an alarm or a call to the developer who did that change, so that they can get alerted and they start working on fixing the bug immediately, because it's their change, they need to do it. So you are not just pushing the responsibility onto the operations team, you are taking ownership of your change. If your change breaks something, then you have to fix it. Doing this will put some responsibility on development team, because they need to be responsible, right? When they are writing code, it emphasizes on that. So the third way is continuous learning and experimentation. So this is more like a theoretical thing where you emphasize, focus on continuous learning, experimentation, and improvement. Are you seeing my screen still?
No, sir.
No,
No,
sir.
it's closed.
Are you able to see now?
Yes, 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 sir.
Yeah. So the key aspects in continuous learning and experimentation are learning from incidents. So whenever some incident happens and it causes your production to go down, rather than playing a blame game like it's your fault or it's your fault, the company should prioritize on finding the root cause, like what went wrong and what made this downtime or application to crash, and what steps are we taking to make sure that doesn't happen again, right? And it also, I think the sharing went off again.
Um, yes, sir. Just now it closed. Now we can able to see.
Yeah, thank you. Yeah, and it also deals with exploring other technologies, right? Let's say if you're working on some Java Spring Boot application, and you see that for your product rather than Java, you may have better results with Python. So you shouldn't shy away from new technologies just because you are in a safe zone or safe box. If something else is providing you better results, then you should explore it and continuously learn it and implement it. So that's what the continuous learning is, the third way among the three ways mentions. So the other framework is team topologies. So rather than the product, the team topologies, it deals with the people who are working with the product. So it categorizes the teams into 4 types based on their interactions and responsibilities. One is enabling teams. It helps others to overcome obstacles. The complicated subsystem teams focuses on areas requiring specialized knowledge, right? So I'll in the next few slides we'll see what this complicated subsystem teams actually means, right? And stream aligned teams, they align with the flow of work from a segment to the business. Platform teams provide internal services to reduce cognitive load on other teams. So the complicated subsystem teams, it deals with, okay, when a person or a resource, if he's talented in building good looking web applications like the front end UI or something, then give him only that. This If someone is good at dealing with database, then give him only that. So by breaking up the team into their areas of expertise, you achieve greater results. That's what that says, right? Complicated subsystem teams. The platform teams, they aim at providing the base pillars. Okay, so um, I don't know how many of you know Terraform, but that's a tool that helps you build cloud infrastructure, servers and all, using code. We'll discuss that in upcoming sessions. But as an example, Terraform uh, platform team, what it does is it will take this Terraform tool, it will write all the modules for you, modules in the sense which you can use separately in your own team or in your own code. You just import those modules and you build your infrastructure in the cloud. So in that way, uh, platform team is reducing the work on you by building the basic modules that you may use, right? So it provides internal services to reduce load on other teams. That's what platform team does. Okay, so in all the places where I go, like to present something or teach something, then the famous question which I got is DevOps dying? Because it's been there for some time, and yes, there are decrease in job postings, there are decrease in job salaries. Does that mean the DevOps is dying? uh, so this is a question asked by people who mostly do not understand what DevOps is and what a DevOps engineer is, right? So DevOps is a philosophy. It doesn't die. It just exists there. If someone wants to implement it, they'll implement it. And DevOps engineer it's a role, right? When if you have searched for any DevOps engineer roles in different companies, each job description for each company differs by a lot. Some expect the DevOps engineer to write code, while some expect them to test the application. Some expect them to do server related things like Linux works, and some expect them to handle the cloud infrastructure, right? So there are no clear boundaries for DevOps engineer. Why all these differences came? Because of the vague definition of DevOps. Each company implemented their own definition of DevOps, and there is no proper way. That's why people identified this problem, and this DevOps engineer broke up into several roles, right? There is a platform engineer, cloud engineer, SRE, and several other roles, right? Platform engineer, what it does, as I said before, they aim to reduce the load on other teams. They own these Kubernetes tooling, or they have this developer experience also. They build basic modules or platform on which other teams can build their own stuff, right? And the cloud engineer, obviously, as the name says, they are experts in cloud. They are professionals in system design. They deal with how the cloud resources are used efficiently while reducing the cost. The company has to pay to the cloud provider. They deal with expertise in scaling the applications, right? Whenever traffic is coming, okay, your product is a hit.
Hello.
Can you please go on mute?
I'll check, sir. 1 minute. I'll check. Dohistory. Dohistory, can you please? No, I cannot do it. You can. Yes, sir. You can continue, sir.
Thank you. So yeah, cloud engineer, let's say if you have deployed your application in cloud and it's a big hit and you have lot of traffic coming in, now you have to increase your resources so that all the traffic can be processed and large number of customers can be satisfied. So you need a cloud engineer who is specialized in scaling things, right? All the cloud resources, you just don't go in the cloud console and start deploying. Okay, give me one server, give me another server, like that. It's always better to use a IAC tool like Terraform, which we'll be discussing later, and you need to use your resources in an efficient way to reduce your cloud bill. And the SRE team, which I am also a part of, they are specialized in maintaining the application, and they deal with the uptime of the application. They want to make sure that the application is up most of the time, right? If there is a large downtime, then SLAs are missed, and SRE team is responsible for dealing that. So they monitor the application using tools like Prometheus, Grafana. They measure the health of the application using several tools, and if there is any change causing the or any code change or any feature change that is causing disruption in these health or stability status, then we send alerts and notify the team responsible for that change so that they can revert it or fix it. So since the most of the DevOps work is divided into several parts, the DevOps engineer work is focused on now CI/CD. They just deal with the pipelines, continuous integration and continuous deployment. Of course, you can see still people following the old methodology where they just put the role as DevOps engineer and add whatever they want in that job description. It's also going on, but yeah, this is the recent news. Like the platform engineer, cloud engineer, SRE, DevOps engineer are all the recent roles that are coming up in last 1.5 year or 2 years, right? Yeah. So this brings us to the famed infinity loop. This is basically the DevOps logo. It basically deals with we have seen earlier, right? our idea, requirements, code, test, all that flow. That flow is the same thing. It's just in the form of infinity loop that was just in the form of a circle. So as you can see in the diagram, it starts with the plan, the one in the back plan. This is basically idea plus requirements. You code it, you build it, test it, release it into the production. These yellow colored ones are all after the code is developed and deployed. The blue ones are the ones which are from idea to testing, right? Once the code is in production, it every change that you make to the application and move that change into the production, it becomes a release, right? Once it is released, it's deployed, operate operations team. I'll tell you different tools involved in each stage of this loop, so that we can understand what each stage deals with. And monitor, there are several tools, as I said before, like Prometheus and Grafana, which is used to monitor the health of the application, right? These are several tools that are used in each phase. For plan, you have planning software like all these Jira software, GitLab, Azure DevOps, whatever it is. And you, for code, the second session which we have on day 2 is regarding this code only. It's how do you deal or maintain your code in any company. So you have several IDEs like Visual Studio Code, Eclipse, and all that, and you store this code in remote repositories like in cloud using Git, GitHub, GitLab, all these things. Mercurial is also a version control system, which we'll be discussing later, right? And once the code is built and ready, once the code is written and ready, the next phase comes is the build phase. So in the build phase, you take, like I said before in the example, if the application is Java application, you have tools like Maven or Gradle, which are used to package all the application into a zip file or compressed format like .jar or something. And this jar file, which contains all your application's code, is deployed in testing environments. Once the testing passes, it will go to the further environments like production and all. So there are several building tools. The most popular one is Jenkins. It's a CI/CD tool, and Jenkins has integrations with Gradle, Maven. These are all interdependent, right? So that's the build phase. And there are several testing tools like SonarQube. So testing just doesn't deal with the application code. Testing is done at various levels, right? In terms of security, to check vulnerabilities, bug fixes. Okay, several testings are there. If when you heard about regression testing or chaos testing, they are testing that deal with the environment of the application, right? So if the application is capable of handling this much traffic or this much load, you test the limits of the application with several forms of this testing, right? So JMeter is one of that. SonarQube is used for vulnerability checks and all that. Selenium is a tool which does automation as well as testing. So this is one of the testing tools. There is no release here. And for deployment, for release also, you use basically Jenkins or something like that, which will push the code into your production environment, right? So deployment, as you can see, Terraform is there. It's IAC tool. It will deploy cloud resources into your cloud. So that's a deployment tool. Jenkins is coming up here as well. So Ansible, Chef, and Puppet are all the same category tools which deal with deploying software into your servers. Docker and Kubernetes are also used for deploying containers or microservices into your production environment. And in operation and monitoring, operation deals with ticketing process, like your customers become clients for you, and when they have some issues or something, they go to this portal, ServiceNow or Zendesk, that portal, they start raising critical like high, medium, low bugs or enhancement requests. And based on that request, there is a operations team sitting there. Whenever a ticket comes in, it's assigned to someone, and they go and start looking into ticket, talking with the client to understand the requirements better and start implementing it. So those all tools, ticketing tools, come under operations. And monitoring is it comes under observability. So observability is basically made up of three things. One is logging, monitoring, and tracing, right? So what are these three things? Monitoring deals with the metrics, like how much CPU, how much memory, the uptime of the application, how much what do they call it? How many times it crashed. All these things come under monitoring. So when you take logging, it deals with the application logs. Application will print out some logs, right? Going into this method, something like that. So all that logs are dealt with uh, logging. And tracing is something which provides traces. What do you mean by traces? When some request comes into the application, uh, which all methods in the code is it hitting, and how much time is it taking in each method, and it gives you the entire flow of the traffic inside your application. Using these traces properly, you will be able to find which method is taking all the time, or which is causing the latency. You will be able to find that application and optimize it better to process the request faster, and that way you can remove all the bottlenecks in your application. So do you think these are a lot of tools that we can see? Then you might know that people build periodic tables out of the available DevOps tools, and this even doesn't cover all the tools, right? So every few days there is a new tool coming up in DevOps, and it's quite hard to keep up. Um, See, as you can see in here, there is a different categories: open source tools, free tools, paid tools, freemium. It's combination of paid and free, and enterprise tools, right? So open source is something which I wanted to discuss in the last session. Um, so what it deals with is open source. There is no monetary things involved. Everybody is free to use, free to contribute, free to write code for a common goal, for a common software, right? The reason, primary reason why DevOps tools are growing so much, and why it's becoming popular, is because of open source. Open source are generally free, and paid software is something they may use. There is a let's say harness, right? It's a CI/CD tool like Jenkins, but it uses some of the open source tools, and they have made it like paid or premium tool. So it comes under freemium. So they set limitations, like a trial version. Until certain limit, if you use it, it's free. If you cross any limits, then you have to pay for it. So those kind of tools come under freemium tools. So we have almost hit 1 hour mark. If uh, anybody wants to take a break, let's have a 5 minutes break. In the
Yes, I
meantime,
will wait for 5 minutes. It's okay. Hello, participants. This is a 5 minutes break. Please take your own time and then return back to the session here itself. Don't disconnect it. Dear participants, don't leave the meet. Be in connect with this. It's a 5 minutes break. That's it. Be connect with this.
Yeah. So before we go any further, does anyone have any questions like in the content so far that has been covered? So I wanted to focus on some one of the important aspects in DevOps, that is CI/CD. Okay, what does it mean, and uh, why is it so important, right? So CI is nothing but continuous integration. So when we saw the our release process cycle, where you have that idea, requirements, code, test, build, deploy, and operate and monitor, right? So whenever you make continuous changes to your application, like improvements or bug fixes, optimize performance, whatever it is, so all that comes under continuous integration. So this basically involves developers frequently merging their code changes into a central repository or some kind of code storage, like git or github, gitlab. Okay, so when developers frequently merge their code changes into central repository, some builds are triggered. Uh, this will be better understood when we go through the day2's Git session. Okay, whenever some code change is made, that Git repo is integrated with a CI/CD tool, which will trigger some pipelines. Okay, so that pipelines, what they do is they automatically run the maven commands to package that into a some .jar file in case of Java application, and even the testing tools are triggered, like SonarQube. They have like DSAT scan, CSAT scan, CV vulnerability scans. All these scans are triggered every time a change is committed into the central code repository. This way, testers are skipping this manual need of testing uh, for each and every change that developers make. So this helps catch integration issues early in, when see you are running these pipelines or tools or commands, whenever a change is pushed immediately into a central repository. You are not even deploying the application into production. The change is being made to just the code storage. Uh, so you are catching the errors or vulnerabilities early before even the code is going somewhere into production or something else, right? This helps catch integration issues early and ensures the code base remains in a working state. And the CD is the tricky part. So there are two definitions to CD actually. One is continuous delivery and the other one is continuous deployment. So continuous delivery, this is something that builds upon CI, by automating the process of releasing code changes. Whenever a code change is made to the central repository, a CI pipeline is triggered. We said, right? It will do the build and package. It will start the testing pipelines, and then once all these are passed, then a CD pipeline is triggered. What it does is it will release the code changes into the production, or not only production. Generally in enterprise level, there are several environments like dev, stage, hotfix, many things like that, and later on it will be prod. So CD pipeline is responsible for deploying the approved code applications, code changes into these environments, including testing, staging, after they have been integrated and tested. So this is continuous delivery, and the other one is continuous deployment. So what continuous deployment does is, uh, it will so continuous delivery is dependent on approval, right? Once the changes are approved only, it moves the changes into different environments. But continuous delivery, it doesn't need any approval. Whenever the changes are passed, all the tests are passed and the changes are ready, it just pushes it. There is no need of any approval there. So generally tools like Jenkins, Bamboo, there are these, right? So Jenkins, Bamboo, TeamCity, these are popular CI/CD tools that handles everything. In this loop, plan, code, build, and test come under CI. Release, deploy come under CD. Operate and monitor can also be included in CD, but they are more like team specific, or even this monitor phase involves deploying the tools like Prometheus or Grafana into the applications. That's why these are also added into the CI/CD loop. If there are any questions so far, just let me know.
Yes, participants, you can respond through thumbs up or you can talk also if you have.
I actually can't see the chat, ma'am. I don't know why.
Okay, okay.
Yeah, if anybody has a question, please speak up.
Yeah, the participants can react also like thumbs up. Yes, someone are doing. Okay.
Yeah, so this session is basically mostly theory. I know it's boring, but it is important to understand what DevOps is. As an interviewer, I have asked many people what DevOps is, and most of these people they were not able to answer, and they are applying for a DevOps engineer role. So that's not an ideal scenario, right? So it's really important to spend time understanding the concept, what actually the role is, and what it deals with before going further into the tools and applications. Like, so in this loop only, let's say you are trying to learn Docker or Kubernetes, you don't know where that fits. You just know that, okay, it's a container, something, it application runs in it, but where does it actually come and fit into the picture, right? So it's important to understand the whole picture first and before going into the each phase and its tools. Yeah. So as I said before, there are a lot of tools that are there in DevOps, and there are new tools coming up every now and then. So how do you master them? How do you keep up with those, right? So what we do is in any DevOps engineer or any person in this particular field, we categorize the tools into several categories, obviously. So in OS systems, most of the DevOps tools work on Linux. Whether you deploy servers in on-premise or on cloud, 95% of the servers run on Linux. So it may be Ubuntu, Debian, Red Hat, Amazon Linux, or anything else. These are all flavors of Linux. Windows is not used anywhere. So Linux, mastering Linux and having knowledge on how Linux works is very important. That's the base. And the networking and security. Networking fundamentals are very important because nowadays microservices is the mostly used methodology or format where you deploy your application. When you divide the application into multiple services, you need to know how these services communicate with each other, which makes you want to learn networking. And if you want to deploy your application into multiple pieces, and these are communicating openly without security, then your application is compromised. So that's why the security aspect is also important, right? Networking and security play an important role. In CI/CD, Jenkins is a free and open source tool, and lot of companies start with Jenkins because it's easy to use. It has lot of community support. There are a lot of plugins that you can use with Jenkins. It can integrate easily with anything, right? So people get started with Jenkins once their companies get started with Jenkins once their product reaches a certain level and it hits the Jenkins limitations, like where you have like hundreds of developers clicking build button multiple times in the same minute. That's when Jenkins starts, slowing down, or it can't extend anymore. Then people go for a premium or paid software like Harness, where there is a these tools run on Kubernetes and it will scale automatically. Of course, you can do with the same with Jenkins also, but it requires a team specializing that or maintaining that. So the fourth one is cloud category, and in cloud, the most used cloud provider is AWS, followed by Azure, Microsoft Azure, and the third one is GCP. So having one cloud knowledge is important to get started, right? And you need to know any scripting language to automate tasks, like uh, small tasks, whatever it is. So Bash or Python are the popular things. If you are into microservices and you want to explore more into microservices, deep dive into them, most of the open source software that are in this microservices field, they are being written in Go language, introduced by Google. So the next one is containers. Docker is having monopoly on container technologies. Of course, there are other things like Podman, but Docker is the default thing which you want to learn if you want to get introduced with containers. We have a session on that on the third day. So the container orchestration, the monopoly is again with Kubernetes only. We have a session on the fourth day on that. We'll deep dive on that day. So when you run these applications in your servers in cloud or on premise or as microservices, you want to know how these you want to know the behavior of this application, right? So if there is how much CPU they are using, how much uptime, how frequently are these crashing, and you want to get an alert whenever okay, there is 100% CPU and your application is crossing the threshold of 80%, and you want an alert to be received whenever this happens. Like whenever your application crosses this 80% CPU limit, you will get an alert and you start increasing the resources so that your application doesn't stall or crash, right? In that case, you need some tools like Prometheus, which will help you do that. And the IAC, the default again tool is Terraform. Of course, AWS has its cloud formation, and GCP has its deployment manager. These are also IAC tools, but Terraform is something which is cloud agnostic. That means with if you learn Terraform, you can write code for any cloud provider. If you learn cloud formation, you are only tightly coupled with AWS. You can't shift into GCP. You have to learn how deployment manager works, right? So being that common thing, Terraform became popular. But Terraform these days, it's shifting from open source to premium model. So that's why there are tools like OpenTofu coming up. But if you learn Terraform, then OpenTofu is also similar because it's a forked repository. Again, what is a forked repository? That will be covered in the day 2 session. So, and the version control. This is the most basic thing expected by any person. In the software world, maintaining the version control system for your code, right? What changes is each developer making? What is the Git repository? What are the branches? What are the strategies? involved in this version control, which will be discussed in the second session, and like tomorrow. Right? Any questions so far? I actually sped up through all the 2-hour content in 1 hour. So yeah, we have a lot of time pending. Okay, so again, these are the next sessions. That is my LinkedIn QR, and that is my blog, where I share lot of DevOps related content. It's on Medium and it's free to read and understand.
What are the day-to-day activities of a DevOps engineer?
Can you please be a bit louder?
What are the day-to-day activities of a DevOps engineer, and how would a how would his day look like?
Right. So as I said before, DevOps engineer is a broad role. It differs from the job and responsibilities, right? Daily, day-to-day activities, as you said. It differs from company to company. And right now, these days, most of the DevOps roles are dealing with CI/CD only. So you interact with developers, you interact with other teams like testing, security, and as I mentioned, all that. Um, you take the code. See, developers write code, they put all that code into some central repository like GitHub, and you are responsible for making the automation there, like CI/CD pipelines. Whenever any change is made, a pipeline needs to be triggered with a webhook, and that pipeline will test that code. Every change needs to trigger one pipeline, so one CI pipeline. Once these tests are passed, it will be merged into approved and merged into some other branch like developer or testing, testing, prod, all these branches, right? Again, when that is merged, it will trigger another CD pipeline, which will deploy these changes into the environment, actual environment. So DevOps, just DevOps, majorly they deal with CI/CD. So Jenkins is a major tool that's there in DevOps. And coming to my other role, which is SRE, Site Reliability Engineering. So that deals with maintaining the application. And you need to run the application with minimal resource usage and make sure that the application doesn't crash. You need to keep it alive all the time, right? So you make use of several tools like Prometheus, Grafana. There are dashboards with all that, hi-fi graphs with different colors. Uh, and whenever some thresholds are, you set up thresholds for the application. You do this chaos testing, understand the limits of the application, and set up the alerts. Right? If your application is using 2 CPU in the morning and 8 CPU in the night, then you as a SRE as responsible for providing that resources at that particular time. In the day, you can just run resources that provides that 2 CPU, but by the time it's night, you need to scale the resources automatically. You don't want to sit manually and do all the time, right? When you take leave from the office, then the application is screwed. So when so you want to automate these things based on the traffic. Your application should scale up, and when the traffic is less, it should scale down. The resources should scale down so that you avoid all the extra computing costs that the cloud provider charges you. So that's the job of SRE.
Do we learn how the automation is done in this workshop?
So yeah, there is a 5-day thing, right? This session was particularly theory because it was important to understand what DevOps is. There were no demos. I thought I would spend all this content 2 hours in 2 hours. So the next session, Git and GitOps. From then we will have demos, right? In each session, I'll show you the terminal. I'll go into a Linux system. I'm on Windows right now. So I'll be telling you what branching is, what Git commands do, how they are important, and what are different strategies used in this Git. So that when you write code and you are asked to commit something or your changes into the Git repo, you are not putting on a blank face. So that happens most of the time in companies with freshers, but attending this GitOps session, you will be saved from that. So the microservices and containers, it tells you clearly the difference between what microservices is, why that came up, earlier what people used to do, how they used to deploy application, and now what they are doing, why is it becoming popular, and which container technology like Docker is adopting these microservices. And there will be a demo on what Docker is, what Docker images are, Docker containers are. I'll show you the commands. I'll show you how an image is built, how that is deployed into a container, right? And hopefully 2 hours is enough for that. I think it will take more than that. So, and the next session is container orchestration. So when you have multiple Docker containers running, you will need some if there are 5 to 6 containers you can manage. I'll show you that in third session, microservices and containers. But when there are hundreds of containers running, how will you manage that? So that is using container orchestration, like a Kubernetes tool. There will be demo again, like how Kubernetes can be deployed, what components are there in Kubernetes, and why Kubernetes is so popular these days. And in the fourth session, that is, fifth session, cloud, IAC, and open source, I'll tell you what are the important. See, in AWS, there are now, I think, 80 something services. But for a person to learn all these services, it will take years. So how to get started with cloud, right? What are the basic core concepts in cloud that everybody needs to know to get started? That will be focused on for cloud. And what is IAC basically? What does Terraform do? How you are deploying this cloud resources using that Terraform, and what is open source software? What is the major communities, and how you can get involved with open source software? That will be covered in the fifth session.
These all are part of CI/CD, right?
No, CI/CD is only Git and GitOps. Uh, the tools will not be covered, but the core aspects of the CI/CD will be covered.
Okay, then the automation related things will happen in Git and GitOps related to CI or
Yes,
CD.
GitOps is basically CD. When developer makes a change, that is Git into Git, that will become CI. I can spin up a demo for that for the second session, if time permits.
Yeah.
Sir, do DevOps include the traditional coding?
Some companies ask you to do that. It depends on which company you are joining. As I said, DevOps is a concept, and different companies have taken advantage of it, and they have their own descriptions for that, right? So some ask you to even test applications that developers write. Some ask you to write applications itself, not from scratch though. Enhancements, basically like adding new features or something.
Okay, sir. Then what about the openings for the DevOps engineer role?
um, I'm not sure if I can comment on that. I actually didn't understand what you meant. Like, what do you mean by openings in that?
Like, taking the companies recruiting the engineers, right?
Yes.
Like that percentage, like, is it higher or low?
Yeah, okay, you're talking about that. Just a second. So this one, right?
Sir, I'm
So
not able to see
see
your
my,
screen.
okay. Yeah, are you able to see it now?
Still no, sir. My settings were wrong.
No, we can see actually.
Yeah, yes, his doubt is related to the side loop
I
slide.
think I have problem my side.
Okay.
Okay, so regarding your question, there is definitely decrease in job postings, but it's not. It's because the DevOps job or their daily day-to-day activities are being split into different roles. So earlier, the DevOps engineer role, it used to focus on everything, like from Linux server management, cloud management, testing, tooling, all these things, CI/CD, everything was stuffed into one role, and wherever there was requirement, people were pushed there into those teams and asked to work on them. Now that was a problem because nobody has a time and expertise on a single thing, right? If you focus on one thing, you will be good at that. So what they were doing is they have realized this problem and they have split the DevOps engineer role into multiple roles, like platform engineer, cloud engineer, site reliability engineer, all these things. So if you are good at Linux, if you understand networking, you are interested in how these devices work, how internet works, how communication happens wirelessly, all these things. If you are interested, then you can go for a cloud engineer, and that specifically deals with microservices like Kubernetes, right? So based on people's interest and expertise, they can choose among these split roles, platform engineer, cloud engineer, SRE, and all that. So for me personally, I liked site reliability engineering and platform engineering, but I got opportunity in site reliability, so I went with that.
Okay, sir. Thank you.
So any suggestions to us based on your expertise related to DevOps and all
As I
this?
said, I included a pro tip. So you have to have these 10, uh, okay, what do they call it? In these 10 categories, at least one tool you have to learn and be expert on, so that whatever the role demands of you, it will be within these 10. That I can guarantee. Uh, Obviously, code is there, scripting, Python. If somebody asks you for cloud, there is point 4 and 9 that deals with cloud. Microservices, 6 and 7 is there. Uh, all these run on Linux, so 1 and 2 points are there. So these 10 are very important. At least one in each category is mandatory.
How long before we could apply for a DevOps role to get higher chances of
So
recruited?
can you speak louder, please?
Okay. How long before we should be applying for a DevOps or a cloud engineer or an SRE role? What are the things that we, as a fresher, what are the
So
things that are expected of us and what we should be thorough with?
as far as I can see in the market, there are companies don't open DevOps engineers for freshers. They will at least say 1 year experience is needed. So get started with systems engineer like Linux administration or cloud support engineer. These will be helpful in getting you the initial roles that are based for DevOps. I started with a support engineer role where I had to support the application. I used to talk with clients, get into calls with them, and deal with the tickets and all. And then I moved into DevOps. Um, so that is one way. And the second way is if you want to directly go into DevOps or some platform engine, whatever the roles which I showed before, do your own personal projects. So set up your own code repo, go and create a account in GitHub, which I'll show you in the next session how to do that. So develop something. Take a code. There is publicly available code for sample applications like demo applications. You don't have to write from scratch. So grab that code and build the pipelines for it, so that whenever you push some change, a pipeline is triggered and deployed into the environment. So do that, and showcase that in your profile. Then companies will know that okay, you are interested, you are doing and exploring things manually of your own interest, and they'll show interest in you. And certifications is one another way to prove that you are knowledgeable in that particular area.
As you said, you need freshers. Freshers are not won't companies won't be giving roles for freshers, right? So
Yeah, not all companies, but some companies do, but there will be heavy competition for those roles. That's why it's important to differentiate yourself from others by having certifications or your own personal projects.
uh, does software engineer role count as an experience for becoming a
Yes.
DevOps engineer?
No, I mean there is two things in experience. They ask for relevant experience and overall experience. What you're talking about is overall experience. Uh, Relevant experience deals with the specific tools and technologies that they are expecting from a particular person in that role.
Could you please tell us about software engineering and systems engineering? What are the differences and similarities between these two things?
Software engineering and
Systems engineering.
systems engineer. Okay, software engineer is basically a broad term for a software developer. So software engineer has to have expertise in front end, back end, like full stack development, as far as I know. And systems engineer, they deal with the Linux systems. They do handle the servers on which the application is deployed, like Linux servers. They do this patching work, vulnerability checking, like um, there are some things like log4j.xml, right? That will handle the logging of the application. There are several vulnerabilities in that. So they will deal, identify all the vulnerabilities. They'll do patching, like upgrade these to the latest version so that these vulnerabilities are removed. So systems engineer deal with the Linux servers. They need to know what Linux is. They are experts in the commands and all. They need to have the good expertise in networking as well, so that like they need to tie up all these cluster servers into a cluster so that applications running in these servers communicate with each other smoothly and efficiently.
Sir, can I know the prerequisites for an
For
engineer, for the DevOps engineer? Like
the
prerequisite.
the technologies which you see on the screen are the prerequisites.
Okay.
You need to know all these to aim for this role. So you guys can connect with me on LinkedIn. So if you are ready with all the tools and technologies and are still not able to find an opportunity where you can apply, I can help you with that on LinkedIn.
Yes, sir. So participants, just check your chat window. There is a Google Form link for your attendance purpose. Uh, if you can't able to access that, I'll send you the mail also. You please put your attendance right now.
Ma'am, it is showing you don't have access to this chat.
Then what you do, I've already forwarded a mail done. Check over it. Can you take that from there? Make yourself mute, please. Just checking. Yeah, Shavi Kaushik, please make yourself mute. Okay, I'm muting it. Yeah, can you access the Google Form through mail at least? Can anyone do respond?
Yes, ma'am, we have submitted now.
Okay, okay. Okay, everyone, please fill the form without fail. That will be considered for the attendance purpose. So shall we close today's session then?
Yes, ma'am. So
Yes, sir.
I know this was a theory session and it completed early.
Yeah.
But
Yes,
following
okay.
sessions, it would take more time than 2 hours, I believe. Yeah.
Okay, sir, understood. Okay, then today's session will close then. I declare today's session is over and I request everyone can leave now. We'll meet tomorrow by the same time. Thank you to our resource person and to all participants. Thank you, everyone. Thank you.
Thank you.
Thank you, sir. Thank you.
Ma'am, can you hear?